So Unit 8, we're going to be analyzing sets of data for one variable, meaning that only one thing is changing. So we're going to be looking at different types of data, different types of ways to represent data. Today, I took 8.1 and I split it up into 2 lessons. So we're doing the first half today. And what we're going to be doing is we're going to represent data on dot plots. And then we're also going to use box and whisker plots, which box and whisker should be a review from last year. Dot plots is actually even easier than box and whisker, although I don't think we do them in 7th grade. So that will be something new. But let me give you some definitions first. So one definition is discrete data. We looked at something else called discrete. What were they? A graph. And what was so interesting about a discrete graph? Yeah, it wasn't connected. They were just a bunch of little dots all around. Same idea here. Discrete data is data that has only a finite number of values, or what we call data that can be counted. So remember how discrete graphs, we were looking at specific points, and it was like the number of jelly beans in the jar. You couldn't connect the points because you can't have half of a jelly bean, right? So we had only whole numbers, numbers that could be counted. Same thing. Discrete data is data that can be counted, or we call it a finite number of values. Finite means that it ends at some point. Okay, second definition that you're going to need for right now is a dot plot. A dot plot is a graph that shows how discrete data are distributed using a number line. So we're going to take a number line and we're going to basically just look at how the data is distributed. Now with a dot plot, you don't necessarily have to do dots. You can use X's, you can use smiley faces, you can use whatever. It doesn't matter to me. We just call it a dot plot because we're looking at the specific point. Okay, so this set of data that I just gave you is what we're going to be working with. So can I have somebody read us the introduction? Who wants to read? Who has a nice loud voice? Okay, Brittany.
Mr. Romero is a health coach and nutritionist. Recently, she encouraged Matthew to eat a healthier breakfast and recommended a cereal with less sugar. There are many different cereals, and it seems like the amount of sugar in each type varies widely. Matthew took a trip to the grocery store and requested the sugar amount in each cereal, that each cereal has.
Okay, so I want you guys, I'm going to give you about a minute to look at this with your groups, but on the left column are all of the different cereal names. On the right column is the amount of sugar in grams for each serving. So you guys know how on a box of cereal it gives you the nutrition information and it tells you how much is for each serving, not necessarily in the whole box. So this is, if you were to have one bowl of cereal, this is how many grams of sugar are in each serving. So what I want you guys to do is look at it with your groups. Look at the different types of cereals and the different amounts of sugar in each one, okay? So, example 1. We are going to construct a dot plot to represent the sugar amount in one serving of each breakfast cereal. You don't have to write those instructions. What I do want you to write is the number line, okay? So, our first example, we're going to take this set of data and we're going to do a dot plot to represent the amount of sugar in each serving. My number line has 22 dashes, okay? So give it 22 dashes because we have to start with the lowest amount of sugar, which is 1 for shredded wheat leaves, and we have to make sure that we go all the way to the highest, which is 22 for puffs, okay? So make sure that there's 22 vertical lines in there for each one, but draw your number line. All right, so what we're going to do a dot plot. The first thing that we are going to need to do is label our graph. So our dot plot, we have to give it a title because all graphs should have titles. What we're going to be looking at is the sugar amount in each of the breakfast cereals. So across the top of your dot plot, make sure you leave yourself some room. We're going to title our plot the sugar amount in breakfast cereal. Yeah, I guess you could have a cereal for it's a non-snack. Naughty snack. That's funny. Okay, so we just want to title it because all graphs should have titles so we know exactly what we're looking at in the graph. And then we also always label our axes in a graph. So along the number line, this is going to be giving us the grams of sugar in one serving. So I want you to title or label the bottom, grams of sugar in one serving. Because we're going to put numbers here, and you need to tell your reader what each of these numbers mean, okay? And what we're measuring in our chart is the grams of sugar for each serving, okay? Okay, so first thing we need to do is we need to label our number line. So the smallest amount of sugar in each serving is 1, and the largest is 22, and make sure then you label all of the other ones. So this is going to be 1, 2, 3, 4, 5, 6. Okay. So make sure you label each of the vertical lines. And now we're actually going to construct our dot plot. So to construct our dot plot, you can do one of two things. We can go to 1 and we can look at, on our chart, how many breakfast cereals have only 1 grams of sugar. Or what we can do is we can just go down our list one by one, and we put a dot or an X or something to represent each cereal that has that many grams of sugar. So let's look at Cocoa Rounds. How many grams of sugar does Cocoa Rounds have? 13. So on our number line at 13, we are going to put an X, or you can put a dot, or a smiley face, or a heart. I don't care. Do whatever you want. Be creative. At 13. So this indicates that there is at least one cereal that has 13 grams of sugar. Okay? What about flakes of corn? How many grams does flakes of corn have? 4. So you're going to put a dot, or an X, or a heart, or a star at 4. Okay? After you start getting multiple, so let's look at, I'm going to skip a couple for right now, and I'll have you guys fill those in. We have Golden Nuggets that has 10 grams of sugar, and Honey Nut Squares also has 10 grams of sugar. So you're going to put one X or dot for each one at 10. So at 10, we're going to put 1 for Golden Nuggets, and 1 on top of that for Honey Nut Squares. Okay? Does that make sense? Okay, so I'm going to let you guys finish your dot plot on here. So remember, I skipped Frosty Flakes and Grape Nuggets, so make sure you put those in and start constructing your dot plot. All right, so what we're going to do is I'm going to have you guys tell me how many on each point on our dot plot that you should have. So how many X's or dots did you have on 1?
1.
Just 1, okay. What about how many on 2? 0. 3? 1. 4? 3. So we should have 1, 2, 3. What about 5? 2. 6? 1. How many was on 7? 4. So I need 1 more. 8? 1. 9? 10. Okay. 11? 2. 12? 1. 13? And then you should have gotten none on 14, 15, 16, 17, 18, 19, 20, 21, and then how many was 22? 1. Okay, so everybody's dot plot should look something like this. You can use X's, dots, like I said. Be creative, I don't care. Okay? What I want you guys to do is, with the people in your group, so the entire group discussion, what conclusions can you draw from the dot plot? Okay, guys, what conclusions can we draw, or what did you notice? 7 grams of sugar is the most. Anything else? Where did most of the grams of sugar fall? Was it like greater than 10, or were most of them 10 or less? Yeah, most of them had 10 or less. How many had more than 13? Just the 1, right? So let's write something like that. Most cereals, let me change colors. So we noticed that most cereals had 10 grams of sugar or less. Per serving. That's good. Okay. So most cereals had 10 grams of sugar or less per serving. So if you guys notice, a lot of our concentration, if we were to cut the graph kind of in the middle, most of the grams of sugar that each cereal had lied on the left-hand side, right? We call this a data distribution. So data distribution is the way in which data is spread out, or some cases it can be clustered together. Okay? So if you look at our dot plot, ours are mostly clustered together, not as spread out. Okay? So definition of data distribution is the way in which the data is either spread out or clustered together. All right, so we have 3 different types of data distribution. First type of data distribution is what we call a symmetric distribution. So symmetric distribution means that the left and right halves of the graph are nearly mirror images of each other. So they don't have to be exact, but it's pretty close. There's often what we call a peak in the middle of the graph. And then here's an example of a more symmetric distribution. So most of the data lies in the middle, and then it's pretty symmetric on each end. Okay, so that's called a symmetric distribution. The next type of data distribution is what we call skewed right distribution. And it's kind of, skewed means that it's less in that area. So skewed right means that the peak of the data is actually on the left side of the graph. So there's only a few data points on the right side. So skewed right means there's less on the right-hand side. So most of our data shows up on the left-hand side, and there's a lot less on the right. That's called a skewed right distribution. So if we have a symmetric and we have a skewed right, we're also going to have what we call skewed left. And it's the opposite of skewed right, basically. Skewed left is the peak, where the peak of data is to the right side of the graph. So that means that there's only a few data points on the left side of the graph. So there's less on the left. So we have here less on the left. Most of our data occurs on the right. So if we were to draw a curve over it, it would look like it's going to the right. Okay. Question to you guys. Let's go back and look at our dot plot that we made. What is the distribution of the sugar amount in one serving of breakfast cereal? Okay, so let's draw a light curve over our dot plot to kind of see where it goes. It sort of peaks over here around 7, and then it starts to tail off, and you have to make sure that your curve goes all the way to the last one. Okay? So ours is kind of not super peak-ish, but if it looks something like that, does that help? Which way are we skewing? Yeah, we're skewing right. Most of our data, even though it's a little more distributed kind of towards the end, but still most of our data occurs on the left side of the graph. So our distribution of breakfast cereal is skewed right. So write that down. The distribution of sugar in breakfast cereal is skewed right. Or I'm sorry, skewed left. No, skewed right. I was right the first time. It's skewed right because most of the data is on the left side. So remember, skew means that there's less on that side.
Oh, but it would have to look like this, right?
It's not going to look exactly like this because not all data is going to look exactly like this, but when we drew the curve over it, there's definitely more data on the left side than there is on the right side. And it's definitely not symmetric because we have that one guy that's 22. That's what's skewing our graph. Okay. So what does that mean? That means that most cereals have more sugar or less cereal? Or I mean, more sugar or less sugar? Less. So this means that most cereals that we looked at have low sugar content. Okay, so of the cereals that we looked at, most of them have a low sugar content because most of them are on the left side of our dot plot. Okay. Definition of a box and whisker plot. A box and whisker plot is a graphical representation that displays the distribution of quantitative data based on a 5-number summary. That's a very mathematical definition. Okay, it means it's a graph that displays the distribution of data based on what we call a 5-number summary. And I'll give you the definition of 5-number summary in just a second. So what is the 5-number summary? 5-number summary consists of 5 parts. Go figure, huh? It consists of the minimum value, the first quartile, which should sound familiar, right? Q1. The median, we know what that is, right? The middle. The third quartile, we call that Q3. And then also the maximum value. So the 5-number summary means that there are 5 really important numbers in your set of data. And we're going to use that 5-number summary to construct a box and whisker plot. Okay, here's your example of a box and whisker plot. So you have your number line, and we are actually going to put values. There will be values on that number line. But your box and whisker plot, you have what is called your box, and the box represents half of your data, the middle half. Inside your box is the median value. The end part, so here's your box, these are your whiskers. The whisker goes all the way to the minimum value, which is the least value in the data set, so we always start with our smallest value. Our first quartile is the minimum to the front of the box. So the quartile 1 is the median of the lower half of the data set. So that means it goes to the middle point in the lower half of the data set. And then we have our middle half here. Your median is the middle value of the entire data set. So this line represents the middle. Quartile 3 is the median of the upper half. So it starts on the upper half, right in the middle, and it goes all the way until the maximum value, which is the largest value. So a box and whisker plot looks like this. It's split up into 4 sections. You have your first quartile, you have this section, you have your third quartile, and then your end section. And so because we're splitting it up into 4 evenly distributed sections, each section represents 25% of the data set. So each section is a quarter, which is why we call them quartiles. Okay, so let's build a box and whisker plot for the amount of sugar in breakfast cereal. So that's example 2. You don't have to write the instructions. Do write this though. So our first step, what we're going to do is we need to separate all of our data into its different quartiles. So your first step is going to be put the data in order. So first thing we need to do is put data in order. Okay, so looking at our data, actually what might help is if you look at the dot plot that we did. So if you go and look at our dot plot that we already made, we have a 1, 3, we have 3 4s. So putting our data in order, we have a 1, we have a 3, we have 3 4s, 2, 3 4s. How many 5s? We have 2 5s. We have a 6, What about 7? How many 7s do we have? 4 of them. 1, 2, 3, 4. We have an 8, 2 10s, 2 11s, 12, then we have a 13, and then we have a 22. Okay? So the first thing we needed to do was put our data in order. Okay? Which you can get off of the chart. Okay? So you'll have to put your data in order off of the chart. And then the next thing we want to do is we want to split it up into the lower half and the upper half. So we need to figure out where exactly the middle is. Find the middle for me. Anybody figure it out yet? Samantha's doing it the way I would do it. I always start at the end and the beginning, and then I go one in, and then I go one more in, and then I go one more in. And where is the exact middle? Okay, which 7? In between? Okay, so your middle should be in between the 4 7s. So what I want you to do is underneath draw a line or a little box or whatever in between those. Split them up. And we call this one our lower half, so label it lower half. So what do you think we're going to call the bigger side? Upper half. So we just split our data into halves, a lower half and an upper half. Now to split it into quarters, we take half of a half, right? A quarter is half of a half. So let's look at our lower half. Where is the median of that lower half? Where's the halfway point? In between 4 and 5. So what I want you to do is I want you to draw an arrow in between 4 and 5. That is going to be Q1. And so what is right in the middle of 4 and 5? 4.5. So Q1 is 4.5. Okay? So do the same thing for the upper half, guys, and that's called Q3. So figure out where Q3 is going to go. What was it? Right at 11, or it's between 10 and 11. So put an arrow between 10 and 11, label it Q3, and so that's going to equal 10.5. So we split it up into our quartiles. The only other things that we have to label are our minimum and our maximum. Our minimum is going to be what? 1. So min equals 1, and our max equals 22. Okay? So label that for me.